Good afternoon, children.
Good afternoon, ma'am.
Good afternoon.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, children. Okay, so you were seeing this question on the screen for, I think, more than 10 minutes. Now answer my question. Give a special name to triangle PAB. Give a special name to the triangle PAB.
It's an equilateral triangle, ma'am.
Very good. It's an equilateral triangle. So when we say special name, it can be, you can say it's a scalene triangle, which is a general name actually. Isosceles is a special name. Equilateral triangle is a special name. Equilateral triangle, isosceles triangle, right angled triangle, right angled as well as isosceles. So right isosceles triangle. So these can be the special names given to triangles. So triangle, in general scalene triangle. So that you cannot say is a special name. So scalene triangle. Isosceles triangle is a special name given to a triangle where two sides are equal. Equilateral triangle is a special name given to a triangle where all the three sides are equal. Right triangle is a special name given to a triangle where one angle is a right angle. So you all know this. Right isosceles. So when the legs are equal, right isosceles is when the legs of the right triangle, they're equal. When these two sides are equal. So say this is 5 centimeters, this is also 5 centimeters. It's also a right triangle. So this one is a right isosceles triangle. This one is a right isosceles triangle. Now name the base. No, this is outside this answer. But since we are in a figure like this, I just want to ask you this question. Name the base. Name the base of this right triangle ABC, right isosceles triangle ABC. Name the base.
BC.
Base or basis? Base or basis?
BC, ma'am.
BC. Okay, Madhumita says BC. Yes, others?
BC, ma'am.
BC. Okay. Ratika also says BC. Okay, so this we have come across this term in the chapter Heron's formula in 9th standard. Heron's formula in 9th standard. This is a very crucial, simple yet very crucial question where we tend to go wrong. The base. Okay, so when the base, the question will be like this: the base of an isosceles right triangle is, say, 20 centimeters. So now it's important to mark it correctly. The base of an isosceles right triangle is 20 centimeters. Okay, find its perimeter. Find its perimeter is a question. Find its perimeter. So now it is important to mark the base correctly. Remember that when the word base is used with respect to a right isosceles triangle, the hypotenuse is the base, not the legs. AB and BC are not regarded as the base. See, you can find the area of this triangle using the formula half base into height. Now, see, please understand, you can find the area of this triangle using the formula half base into height, where the base is 5 centimeters and the height is 5 centimeters. That's fine. So now I'm not saying BC is not the base, AB is not the, I'm not saying that. If in the question you have this term base of an isosceles right triangle is 20 centimeters, where will you mark 20 centimeters is the question. Is AB 20 centimeters? Is BC 20 centimeters? Or is AC 20 centimeters? So in this situation, when the term or the word base is used, it refers to the hypotenuse only. So you have to draw the figure like this. For this question, You'll have to draw the figure like this. Okay. So you can call the triangle ABC, right angle at B. The base is 20 centimeters, which means AC is 20 centimeters. AC is 20 centimeters. The hypotenuse is the base. The hypotenuse is the base in an isosceles right triangle. So you'll have to call this one X and X. Okay, because it's isosceles, no? So the legs are equal. The legs are equal. The hypotenuse cannot be equal to any side. The hypotenuse is the longest side in the right triangle, so that cannot be equal to any of the other sides. So the equal sides are AB and BC. Always in a right triangle, in a right isosceles triangle, the legs are the equal sides. The legs AB and BC, the legs AB and BC, they are the equal sides. So if this is the question, you will mark AC as 20 centimeters because the base is 20 centimeters. Then the equal sides are AB and BC, X, X. Now you'll use Pythagoras theorem. You will say X squared plus X squared is equal to 20 square. You'll use Pythagoras theorem in right triangle ABC by Pythagoras theorem. AB square plus BC square is equal to AC square. So X squared plus X square is equal to 20 square. So you'll work this and you'll find X. Once you find X, you know you've found the length of AB and BC. And then you can find the perimeter. And then you can find the perimeter. Okay. You should remember that. Just remember this figure that's all in your mind. You just remember the figure. So much of theory you don't have to remember. Just remember this figure, right triangle, right isosceles triangle. This is the base. This figure should be in your mind. That's all. So far what we, we understood. Remember this figure. It's a right triangle. It's also an isosceles triangle. Then the hypotenuse is the base. Keep this figure in your mind. That's all. So you should see that figure. If you close your eyes, you should be able to see that figure. Right triangle, equal sides, base. All right. Yes, children. So as Madhumita rightly said, this one is a equilateral triangle. PAB is an equilateral triangle because we know that PA is equal to PB. Okay. And now this is, so if these two sides are equal, these two angles are equal. These two angles are equal. So if this is X, this is also X. So X plus 60 is equal to 180. X plus 60 is equal to 180. So that means 2x plus 60 is equal to 180. 2x is equal to 120. X is equal to 60 degrees. So this is 60 degrees. This is also 60 degrees. So since all the three angles are equal to 60 degrees, it's an equilateral triangle. And the question is to find PAB. See, we found PAB. PAB is 60 degrees. Then we need to find AB. Because it's an equilateral triangle, all the sides are equal. So since PA is 5 centimeters, PB is also 5 centimeters. Now because it's equilateral, AB is also 5 centimeters. So I'll share this, meaning I'll upload this in the portal, children. You can write it later. After the class, maybe you finish your lunch and you can complete this. Or if you understood this one, any questions?
No doubts, ma'am.
Okay, thank you, Sachin. Thank you. I'll let you know. Yeah. So here, now is AR equal to AP? Is AR equal to AP? No? Or can't say? Yes, no, or can't say?
Ma'am, it's the radius of the circle, so it will be equal.
Yeah. So AR is equal to AP. AR, no doubt, is equal to AP because A is the center of this circle. A is the center of the circle. So radius AR is equal to radius AP of the same circle. AR is equal to AP. But I think some of you might have got caught with that tangents from an external point of the circle, because we've been doing that, in many cases. So it's not tangents from an external point of the circle are equal. So here to these three circles, there are no tangents at all, because the three line segments are AB, BC, and AC, and all are getting, meaning they're all inside the circle. So to these three circles, there are no tangents. To these three circles, there are no tangents, because the line segments available here are all inside the triangles. Okay. So AR is equal to AP radius like XX. Then BP is equal to BQ, correct?
Yes, ma'am.
Why?
Radii, ma'am.
Radii of the circle with center B. So Y. Then CR is equal to CQ. CR is equal to CQ. Same reason. Radius of the third circle with center C. So Z. So this point is R, children. This point is R. This point is Q. This point is P. This point is P. This is R. This is Q. And of course, this is C. So ABC centers of the three circles. The three circles touch each other. They are not intersecting circles. They are touching circles. They are touching circles. They only touch each other. That means they have only one point in common. Intersecting circles will have 2 points in common. There are 2 points in common. Touching circles will have only 1 point in common. So see here, this circle and this circle have only this point in common. This point, R in common. These two circles have Q in common, and these two circles have P in common. Touching circles have exactly 1 point in common. So these are touching circles. All right. So I was telling you that this is R, this is Q, and this is P. So as we all understood, AP is equal to AR, XX. BP is equal to BQ, Y. CR is equal to CQ, Z. Now, what is AB, children? X plus Y, right? X plus Y, right, children? AB is X plus Y. And how much is it? How much is X plus Y?
5 centimeters.
5. Very good. How much is BC? 7 centimeters. But what is BC? Y plus Z. Y plus Z is equal to 7. And what about AC? AC is given to be 6 centimeters. AC is given to be 6 centimeters. And in the figure, by the figure, what is AC? X plus Z. Very good. X plus Z is equal to 6. So now we have constructed 3 equations. Now let's add the 3 equations. So you will get 2x plus 2y plus 2z is equal to 18. And x plus x is, add the 3 equations. Add all the 3 equations. So you get 2x plus 2y plus 2z is equal to 18. Take out 2 common. X plus y plus z is equal to 18. So x plus y plus z is equal to 18 upon 2, which is 9. But what is x plus y? 5. So 5 plus z is equal to 9. So z is equal to 4. If z is 4, you can find the others. Now you can find everything actually. Or using the same idea, you can continue. X plus y plus z is what? 9. But what is y plus z? This is 7. Y plus z is 7. So x plus 7 is equal to 9. X is equal to 2. You can also substitute in these equations, children. See, once you get this equation, you can find the other values, find x, y, and z in different ways. So now we have to find y. So to find y, maybe you can take up this equation. Y plus z is equal to 7. And what is z? y plus z is 4 is equal to 7. So y is equal to 3. You can find y like this. Or you can also use x plus y is equal to 5. But what is x? 2. 2 plus y is equal to 5. So y is equal to 3. You can find it like this. Or you can take up this equation x plus y plus z is equal to 9. But what is x plus z? 6. What is x plus z? 6. So 6 plus y is equal to 9. Y is equal to 3. So you can substitute, in different equations and find the values of x, y, and z. So there is nothing like you have to substitute it like this. Once you get x plus y plus z is equal to 9, you can find the values of once you get the equation x plus y plus z is equal to 9, using this equation and these equations, you can find the values of x, y, and z, like the way you want. So now tell me, children, let's do it quickly again. Yeah, tell me. What is x plus y fast? X plus y?
Five centimeters, ma'am.
Y plus z?
7 centimeters.
7
7.
centimeters.
Yeah, x plus z?
6 centimeters.
6. Next what? What should we do next?
Add all the three equations.
Add. So what do you get?
2x plus 2y plus 2z is equal to 18.
Okay. Then
2 times x plus y plus z is equal to 18.
okay.
And then x plus y plus z is equal to 9.
Is equal to 18 by 2, which is 9. So now you can substitute x plus y is what? 5. So you'll get 5 plus z is equal to 9. So z is equal to 4. So like this, you can find everything. But you have to find only the radius of the circle with center A. The question is to find the radius of the circle with center A. Center A meaning you should find only the value of x. You should find only the value of x. You don't have to find y and z. So only x means you substitute for y plus z. What is y plus z? 7. See, they're asking you to find the radius of the circle with center A. That means you should find the value of x only. So once you get x plus y plus z is equal to 9, substitute for y plus z. Y plus z is 7. So x plus 7 is equal to 9, x is equal to 2. So the radius of the circle with center A is equal to 2 centimeters. All right, children?
Yes, ma'am.
Okay, so that's what is here. Yeah, there's the next one. All right. So in this figure, you can see a right triangle ABC. You can see a right triangle ABC, right angle at B. The legs of the right triangle given to you, AB 24 and BC 7 centimeters. AC you can find using Pythagoras theorem. So it will be what? 25. You can find AC using Pythagoras theorem. It will be 25 centimeters. Now the question is to find the value of R. Find the value of R, the radius. Okay. So now join now. Supposing we mark the points of contact. I think I've marked here. Okay, I've used the formula here, but I'll not use the formula here, children. 1 minute. Okay. So let me mark this point as like P and Q. All right. PQ. What is P? The point where the line segment AB touches the circle. So AB is a tangent. AB is a tangent to the circle at P, and BC is a tangent to the circle at Q. The points were not marked. We have marked it. Now let's mark the center of the circle also as O. Let's mark this one as O. So OP is a radius. See, what are we joining? We marked off the points of contact P and Q, and we join O, Q, and OP was already connected. If it was not, then you'll have to connect OP. So now here you can see a quadrilateral. You can see a quadrilateral OPBQ. You can see a quadrilateral OPBQ. Now you will have to prove that this quadrilateral is a square. So similar to what we did yesterday, this is 90 degrees because radius OP is perpendicular to the tangent AB. This is also 90 because radius OQ is perpendicular to the tangent BC. And since three angles of the quadrilateral are right angles, the fourth one also has to be a right angle. Hence, OPBQ is a rectangle. In the rectangle, one pair of two pairs of adjacent sides. One is enough. So in this rectangle, one or two pairs of adjacent sides are equal. So you can either mention OP is equal to OQ because radii, or you can say BP is equal to BQ. Tangents from an external point of the circle are equal. BP, the external to the circle, B is an external point. To the circle, B is an external point. BP is equal to BQ. Anything. So the quadrilateral we proved is a rectangle, now is a square. Just a minute, children. Yeah. All right, so now it's a square. OPBQ is a square. So that means OQs already R because radius. BQ is also R. PB also is R. See, BQ and BP, they cannot be the radius of the circle. Their lengths are equal to the radius. That's all it is. BQ and because we have marked BQ and BP as R, we know that they are not the radii to the circle. The length of BQ and BP is equal to the radius of the circle. They measure like 5 centimeters, 6 centimeters, but they are not the radii. So this is how we have to start. You'll have to prove that this quadrilateral is a square. So first find all the angles of the quadrilateral. Each angle will be a right angle. So it is a rectangle. In the rectangle, one pair of adjacent sides is equal. Therefore, it is a square. Now that it's a square, all the sides are equal. So OP, OQ, BQ, BP, all equal. And you can mark them as R. Or if you're not comfortable marking it as R, you can call it as X. You can call it as X. Okay, so now this whole thing is 24. AB is 24. AB is 24. How much is BP? How much is BP? R. So what is the rest of it? AP.
24 minus R.
Correct. PQ, R, R, R. This one is R. This one is R. So the rest of it, this one, that is BP is R. So AP will be 24 minus R. 24 minus R because AB, the full thing is 24. And BP is, so of 24, BP is R. So the rest of it will be 24 minus R. Similarly here, this is R, but the full thing, BC is 7 centimeters. BC is 7 centimeters. BC is 7 centimeters. BQ is R. See, if you all understand, I'm sure, but just in case you have a doubt, why can't it be R minus 7? Supposing you have a doubt, then I can tell you, please work it like this. You please work it like this. In case you have that question, please work it like this. Write AP plus PB is equal to AB. Okay, so AP plus how much is PB? R is equal to AB, which is 24. So AP is equal to 24 minus R. Similarly, BQ plus QC. BQ plus QC is equal to BC. How much is BQ? R plus QC we'll find now in terms of R is equal to 7. So QC is equal to 7 minus R. So QC is equal to 7 minus R. This one. This is R. So this one is going to be 7 minus r. Now name the name all the points you can see in this figure, children. Name all the points which are marked here in this figure. All the points. Name all the points marked here. Like point O, point A.
Point A, point B, point C, point Q, and point O, ma'am.
No, once again, slowly.
Point A, point B, point
No,
C.
leave the word point. No, leave the word point. A,
B, C, O, P, Q, ma'am.
O, P, Q. A, B, C, O, P, Q. Okay,
Yes,
now, yeah. Tell me the points that lie inside the circle.
Point O, ma'am.
Only O. On the circle,
Point P and Q, ma'am.
P and Q. Points P and Q. Outside the circle,
Points A, B, and C, ma'am.
A, B, and C. Now, so A, B, C are points.
External points.
External points to a circle. Exactly. External points to a circle. So name the tangents from A.
AB and AC, ma'am.
No, name the
AR
tangents.
and
Okay.
AP.
No, I'll correct my question. Name the tangent segments from A.
AR and AP, ma'am.
AR and AP. Name the tangent segments from B.
BP and BQ, ma'am.
Name the tangent segments from C.
CR and CQ, ma'am.
CR and CQ. Now you said AP is equal to AR. So how much is AR then?
24 minus R.
24 minus R. Then how much now? CQ is equal to CR. So what about CR? How much is it?
7 minus R, ma'am.
7 minus R. But what is the actual length of AC by Pythagoras theorem? By Pythagoras theorem, what is the
25.
actual length of AC?
25.
25 centimeters. Okay, because AB squared plus BC squared is equal to AC squared. So 24 squared plus 7 squared is equal to AC squared. This, you know. So AC squared is equal to 576 plus 49, 625. Square root of 625, 25 centimeters. So AC is equal to, so AC is 25 centimeters. AC is 25 centimeters. But what is AC? AR plus RC. AR plus RC is 25, correct? So AR is 24 minus R plus RC is 7 minus R is equal to 25. So this is 31 minus 2R is equal to 25. On working this, you'll get minus 2R is equal to minus 6, R is equal to 3. So the value of R or the radius of the in circle, the radius of the in circle or the in radius is the radius of the in circle. In radius is the radius of the in circle. So the value of R is 3 centimeters. Understand, children?
Yes, ma'am.
Class
Yes,
answer
ma'am.
emoji, raise your hand. Admita, Sashank, Krishmi, Rakshita, Raghavi, Ritika, Tanishka, Arjun, Prajit, Florentina. Hope Ranjan is there. Okay, very good, children. Okay. Not Madhumita. I want somebody else to repeat the whole proof. Because she's always an active participant, Madhumita. And a few others. So, yeah, PQ. Yeah. Quickly tell me. Fast. Okay, answer my questions. What's the measure of this angle?
90 degrees, ma'am.
What's the measure of this angle?
90 degrees, ma'am.
Then how much is this angle?
90 degrees, ma'am.
So if each angle of the quadrilateral is 90 degrees, then OPBQ is a
Rectangle.
rectangle. It cannot be a square. It need not be a square. If each angle is a right angle, it's a rectangle. Now you should prove that the rectangle is a square. How do you do that, Shashank?
Ma'am, PO is equal to PQ. That is, adjacent sides are equal of the rectangle. Therefore, it is a square.
Therefore, it's a square. Okay. Now that it's a square, all the sides are equal, correct?
Yes, ma'am.
Yeah. Now tell me after this what? This is R. Then how much is this one?
Ma'am, 24 minus R.
Very good. This is R. So how much is this?
7 minus R.
If this is 24 minus R, how much is this one?
24 minus R.
Why?
And because tangents are equal, tangents from an external point are equal.
Okay, very good. Then what else can you fill in this figure?
Ma'am, 7 minus R. R
For RC. This one is also. Yeah, next Shashank, after this.
Ma'am, AC is equal to 25 centimeters by Pythagoras theorem.
Very good.
After that, 24 minus R and
No,
7.
AC can be split as AC is equal to
AR and RC.
AR plus RC is equal to 25. Okay, then AR is
24 minus R plus
7.
7.
Yeah,
But the plus applies for the whole, right? No,
yeah, but that will not
Yes,
change.
ma'am.
No, so I didn't put a bracket. Okay, I'll
Okay,
put a
ma'am.
bracket.
No,
Yeah,
ma'am.
no, yeah, you're right. Actually, yes, but since the signs will not change, I didn't put a bracket. Is equal to 25. So on opening the bracket, you'll have this one. Yeah. So on solving, R is equal to 3 centimeters. All right, children.
Yes, ma'am.
Very good. So you can also remember this formula. In radius is equal to 1 mark for 1 mark. MCQs. You don't have to spend so much time working all this. So you need some shortcut note to finish it quicker. So in radius is equal to sum of the legs minus the hypotenuse by 2. A and B are the legs of the right triangle, and C is the hypotenuse. In radius is equal to sum of the legs minus hypotenuse by 2. Sum of the legs 24 plus 7 minus hypotenuse by 2. 31 minus 25 by 2. 6 by 2, 3. Finished. That's all. You should handle MCQs like this. You should not work this elaborate procedure. That is only if it is for 2 or 3 marks. If it's not for 1 mark, you have to show the steps. Because if it is for 2 or 3 marks, you cannot change the working, no? Whether it is for 2, 3 or 4 marks, you can only present this answer. You cannot you cannot change it for 2 marks, 3 marks and 4 marks. 1 mark, you don't have to show any steps. Use this formula and get the answer. If it is not for 1 mark, if it is for 2, 3 or 4 marks, you'll have to present this working. The working is the same irrespective of the marks. Get it, all of you?
Yes, ma'am. Ma'am, can we use this formula for 2 or 3 marks?
No.
Okay, ma'am.
I don't know. That's what, see, again, things are different. I don't know if your teacher will encourage that. It's better you show step, because when it's for 2, 3 marks, you are awarded marks for every step, like every milestone in the answer, you're given marks. So in that sense, if you use a formula, I don't think she'll be happy. Maybe for 2 marks, you can See, certain things, we cannot go and ask the teacher, right? So it's better we are safe and we present the detailed working. Correct?
Yes, ma'am.
Yeah, we may have a few questions to ask, but it's not, even if the teacher is approachable, you cannot go to the teacher every time and ask her, can I do this answer like this? Can I do that answer like that? So it's better we are safe and you present the answer in detail. That's it. So that you don't have to be scared if she's going to give you or not give you marks. She will give you. Yeah. Fine, children. For MCQs, use the formula. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Yes, Rakshita, now tell me this formula in words. Tell me
Yes,
the formula in words. In radius is equal to?
Ma'am, in radius is equal to legs of the triangle minus the hypotenuse by 2.
Okay, so this one means legs of the triangle, is it? Okay,
Yes,
who can modify that?
Ma'am,
Rakshita,
can I?
is right.
Ma'am, in radius is equal to sum of legs minus hypotenuse by 2.
Yeah, Ritika, yes. Sum of the legs. In radius is equal to sum of the legs minus hypotenuse by 2. Okay. So here I'll just, like include that this answer also and then share the presentation. So here I think I've worked only using the formula. I've worked only using the formula here. Okay, there's another method. Okay, so see here, children, you can also find the end radius using this formula, semi-perimeter minus hypotenuse. End radius is equal to semi-perimeter minus hypotenuse. This is the other formula. End radius is equal to semi-perimeter minus hypotenuse. That is C. See, C is always A and B. Normally in a right triangle, the letters A and B represent the legs and C represents the hypotenuse. So S minus C means S is semi-perimeter. We have seen this letter in Heron's formula last year. S is a semi-perimeter minus C. C means the hypotenuse. S minus C, semi-perimeter minus C. So let's use that, semi-perimeter minus C. What's a semi-perimeter? A perimeter is 24 plus 7 plus 25 by 2. Oh, sorry, this is the perimeter, sorry, perimeter. So semi-perimeter will be 24 plus 7 plus 25 by 2. By 2. So we'll go 31 and 25. So 56. Semi-perimeter is 56 by 2, which is 28. Okay, so 28 minus hypotenuse. C is hypotenuse. 25, 3. So like this also you can find. See, wide, how do we have that formula? It's like this. In radius is equal to A plus B minus C by 2, right? Now, just if you add C here, this is the perimeter, right? If you modify this formula, are you listening?
Yes, ma'am.
All of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So we're just modifying this formula, children. What are we modifying? This formula which we know, this formula also can be derived. Actually, we, like that's what we did here when we found the radius. Here we actually derived it, but that's what I said. The presentation is not here. I'll include those slides and then share and then upload this presentation in the portal. So now understand well. Just give me some time because I need to include that and then upload. No, so just give me some time. I'll upload it and let you know. And in future, I'll be sharing the links. You will get the link when it's uploaded. You don't have to go to the portal and keep checking if I've uploaded. Once I upload, I'll share the link with you. I'll share the link with you. You can go and check, or I'll send a message on WhatsApp, whatever. Okay, so I'm saying that we are just, using this formula a plus b minus c by 2. So we are like, a plus b, you want c also, because a plus b plus c, is perimeter. Okay, so you know that a plus b plus c is perimeter. So you're simply adding c. But if you add c, you should subtract c. Then that minus c, you write it as it is by 2. See, in the numerator, you have a plus b. So you want c also, a plus b plus c, you want plus c also. Why? Because a plus b plus c is the perimeter. So you want it complete like that. A plus b, you are adding c by yourself. Because a plus b plus c is the perimeter. The sum of the three sides is the perimeter. But how can you simply add c like that? So if you add c, you should also subtract c. When you add something, subtract the same thing. So this part has happened because you have done something. You added c, so you removed it. Then that minus c, which is already there, minus c by 2, by 2. Or let me do it like this, 1 minute. In radius is equal to a plus b minus c by 2, right? This is the formula, right, children? A plus b minus c by 2, correct? Is this the formula? A plus b minus c by 2? Say yes. Why? In radius is a plus b minus c by 2, right?
Yes.
Yes, ma'am.
Yeah. So you add c and subtract c here. So if you add something, you must subtract the same thing. So that makes it, this is nothing but perimeter. Perimeter, I'll write P for perimeter, okay? I'll just write P for perimeter. Minus 2c by 2. Perimeter minus 2c. This one is minus 2c by 2. So that is perimeter by 2 minus 2c by 2. Because if you have a minus b by 2, you can write it as a by 2 minus b by 2. So p by 2 minus 2c by 2. So that's nothing but p by 2 is nothing but semi-perimeter. Perimeter by 2 is nothing but semi-perimeter. Perimeter by 2 is nothing but semi-perimeter. Minus, that's why in radius is also s minus c. That's why in radius is also s minus c. Semi-perimeter minus hypotenuse. So these formula, these two can be used to find the in radius of the circle inscribed in a right triangle only. Not for, because the formula is like that. No, hypotenuse, where will you get? A plus b minus c, that is sum of the legs minus the hypotenuse by 2. So this is not for every triangle. See, you cannot use this formula for, if you have a triangle like this, some triangle, scaling triangle, okay? For this one, you cannot find radius using this formula, because which is the hypotenuse? There is no hypotenuse. It's not a right triangle at all. So this formula is only for a right triangle and for the circle inscribed in the right triangle, not for any other triangle. You can't use it also because there are the words hypotenuse, legs and all that. So it is only for a right triangle. Okay. Just a minute. I'll let you know. I think I'll wind up the session with this one. Because some of you might have had lunch, might have not had. I'll just wind up the session with this one, children. Before that, just in case you want to, you can take a screenshot just in case you want to revise or practice or you want to complete it by yourself before I upload in the portal. You can take a picture. Take a screenshot if you want to work it. I'll upload it in the portal, but before that, if you want to complete by yourself, you can take a screenshot now. See, children, don't get confused why she's found Y here. We had marked this one as X, but here in this working, I have marked it as Y. Here, it's, you understand, it's okay. No, so see here, APAR is Y. Y you have marked. So we have found Y here. Suddenly don't get confused. She said find X, now she's found Y here. We marked, when I explained, I marked X here, X and X here. But in this working, I marked this one as Y. That's why we found Y here. So in this presentation, you will see I found the value of R only using the formula. Only using the formula. So here you can see sum of the legs minus hypotenuse by 2, that formula. Or you can use this formula. Or this formula, semi-perimeter minus C. This is one working. Or you can use this formula. R is equal to S minus C. But for that, you'll have to find S, right? So that's what I found here, 28. So 28 minus C. This is the formula. This is the formula. R is equal to S minus C. So S is what? Semi-perimeter. A plus B plus C by 2. I've done it only using that formula. Only using the formula here. This method which I just told you, this is R, this is 24 minus R, that I'll have to create the presentation and then upload it. So give me some time for that. Yeah. Yes, children. So now join OQ, OR. There's nothing to explain in the question, children. Some values are given, that's all. There's nothing to explain. If the question needs to be explained, I would definitely read and explain the question. Here, there's nothing to explain in the question. The values are given. So the figure is important and you can understand the figure also. Figure at a glance, we understand. Just looking, you can understand. There's a triangle PQR and, it's in circle. So that's why I'm directly starting the answer. So join OQ, OR and OP. That is, you will always join the center to the vertices, the center of the circle to the vertices of the triangle. You'll always join the center of the circle to the vertices of the triangle. So now we have divided the whole triangle into 3 smaller triangles. We have divided the whole triangle into 3 smaller triangles. So name the triangles. Name the triangles.
Triangle OQ, triangle OQR, and triangle ORP.
Correct. So triangle POQ, triangle QOR, and triangle POR. These are the triangles. These are the triangles. Now, if you have to find the areas of these triangles, you need the altitude. So join. These are the points of contact. These are the points of contact. So maybe we'll call them M and N. Join OM, ON. Because we need altitudes and it's 90 degrees here because radius perpendicular to tangent. Radius perpendicular to tangent. And this, it's not marked 90, but it is 90. For the same reason, radius perpendicular to tangent. Now, if I move, Yeah. Area of triangle POQ plus area of triangle QOR plus area of triangle what did I write? POQ, QOR, POQ. Sorry, POR is equal to what, children? Area of triangle is equal to area of triangle
PQR.
PQR. Area of the whole triangle PQR is equal to area of the whole triangle PQR. Now, Rakshita, how do you find the area of triangle POQ? Half base into height. So tell me the base of this
Yes, ma'am.
triangle. Tell me the base.
Ma'am, PQ.
PQ into the altitude.
OM.
OM. Very good. Then plus half into base of QOR.
QR.
Yeah. And the altitude.
OT.
Very good. Then for POR.
Half into PR into ON.
Is equal to what is the area of triangle PQR given in the question?
189 centimeters square.
So can we write 189 here? Is equal to
Yes,
189. Yeah. So half into, let's substitute half into what is, how much is PQ? So we have to do something now. Now go back to the question. OT is given to be 6 centimeters. OT is 6 centimeters. How much is QT? This is 12. So, okay, not Rakshita, somebody else say if QT is 12, which is the other segment which is 12 centimeters?
QM.
QM. QM is also 12. And TR is 9. If TR is 9, which is the other segment which is 9?
NR.
NR is 9. NR or RN is 9. Okay. So we have used all this information. 6 centimeter, we marked 12 and 9. We marked all this. And area of triangle PQR we have used here, 189. So that means PM is not given. We don't know about PM and PN, we don't know. So we'll call it X. And if OT is 6 centimeters, OM is also 6 because radius. ON is also 6, radius. So OT, OM, ON, because OT is 6 centimeters, OM, ON are also 6 centimeters radius. So now tell me half into base.
12 plus X. X plus 12.
Very good. X plus 12 or 12 plus X, whatever. X plus 12. Yeah, into altitude.
6.
6 plus half into.
Ma'am, you have to put a bracket with.
Yeah, that's what I'm correcting. No, I'm correcting it. Yeah. You can even take out, like the radius common instead of writing half everywhere. 1 minute, children. So half into PQ into how much is OM? 6, right? Okay, no problem. Yes. That's okay. No, if you're okay, I can just say something else. Half into PQ into OM is 6 plus half into QR into OT is 6 plus half into PR into ON is 6 is equal to 189. So it'll be 3, no? 2 ones are 2.
Yes, ma'am.
3. Yeah, so you'll get 3 PQ plus 3 QR, correct? Plus 3 PR is equal to 189. Now you can take out 3 common. It'll be easier. Like I'll show the earlier working also. So you can now write PQ plus QR plus PR. is equal to 189. Now we can substitute. Oh, sorry, 3 can go for division there. So PQ plus QR plus PR is equal to 189 by 3, which is 63. Now take the values. How much is PQ? What is PQ? X plus 12.
X plus 12.
Plus 12 plus
X
9,
plus
21. 9. Yeah, QR is 12 plus 9, 21. Plus X plus 9 is equal to 63. So you get 2x plus 42, correct? Correct, children? 42, yes. How much is this? Am I working it correctly? Calculation?
Yes, ma'am.
Yeah, so we find X is equal to 10.5 centimeters. The question is to find PQ. How much is PQ? X plus 12. PQ is X plus 12.
22.5.
All right, children?
Okay, ma'am.
Yeah, take a screenshot. Taken, children?
Yes, ma'am.
I'm going to clear the slide now.
Taken, ma'am.
Now let me show you by like substituting straight away. Okay, so it will be half into, or maybe at this point you can at least take out half common. Yeah, tell me, children, half into? Yes. Okay, I think you're not able to read my mind. Let me know. So it amounts to 10.5. You can also work it like this. So x is 10.5 and we have to find PQ. PQ is x plus 12, 10.5 plus 12, 22.5 centimeters. Is that fine, children? Take a picture.
Taken, ma'am.
Now I'll just clear the slide. You can take the picture of the question alone. Yeah, this is how the question will be like. The figure before the construction we do. Done, children?
Yes, ma'am.
Yeah. Oh, I didn't show you the answers. Yeah, this one I think I've worked it in the same way. So you can take a picture of this one also. This is the answer, like what we just understood. This is the answer. All right, children. So that was it for today's session. Thank you so much. You may leave the call, children. Regular class tomorrow at the center. Thank you.
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Thank you, ma'am.
Thank you, children.